Hello friends, in this video we'll see what is weight and bias in deep learning, what is the importance of weight and bias in artificial neural network. So what is the weight? Weight is the learnable parameter in the neural network. So here in this figure you can see here there are inputs and weights are also assigned. So it control how the input influences the neuron output. So it will tell how weight is responsible for output of the neuron. And you can think of weight as a strength of importance factor attached to the input. So if there is higher weight, then there is stronger influence on the neuron output. So this is nothing but neuron. If the weight is higher, then it has and then it is influenced by the weight. If there is lower weight, then again there is weaker influence on the neuron output. So mathematical role of the weight. So here you can see the neuron, how the neuron output calculated. It is through W1 x1 plus W2 x2 plus W3 x3 plus bias. So here you can see there is input, then input is multiplied with the weight, and then it is then summation is done with the bias, and then neuron output is calculated. So weighted sum is passed through the activation function. Now, what is activation function? Activation function is used to activate the neuron. So this is how the complete process is defined. There is input, there are weights, and then input and weights are multiplied, and then bias is added. Then it is passed through activation function, and then finally you will get the output. So what is activation function? That we'll see in detail in upcoming lectures. So example of weight. So here you can see um, um, there is input x has x1 has 5, x2 is 8, and w1 is 0 0.6, w2 is 0 0.3, bias value is 0 0.5. So here the weight and that is 5 into 0 0.6 plus 8 into 0 0.3 plus bias is added, then you will get the output as z is equal to 5.9. So weight, what is the weight? First of all, let us see what is weight. So suppose weight are different from the inputs. So weight is different and input is different. Here you can see x is equal to 10, w is equal to 0 0.5. So weight is different and input is also different. And so here 10 is the input, 0 0.5 is the weight. So difference is weight is learned by the neural network during the training. How does ANN learns from the training? This is important concept. Initially, the network does not know correct weight, so any random value of the weight is selected. Then what happens by the time output is calculated, so it is compared with the actual value. If there is error, so how error is calculated here? It is actual minus predicted value. If there is error, then weight will be updated. So I told you weight is weight is updated through the error. So what is loss function? So loss function tell the neural network about loss, means how the loss function is calculated. It is actual output minus predicted output. So this is how the loss function is calculated. So what is the objective? Objective is to minimize the loss. Then how to minimize the loss? It is through updating the weight. So at the output, the again loss is calculated. If there is loss, then again through back propagation technique, the weight has been continuously updated. So how long this procedure is continued? This procedure is continued until the loss is minimized or loss is close to zero. So why weights are updated repeatedly? The reason is to minimize the loss. So here you can see at iteration number one, the weight is 0.50. Then output is calculated. There is loss. So again, new weight is updated 0.47, 0.44, 0.4. for 2. This procedure is repeated until the loss reaches to minimum value or close to 0. So this is how the loss is calculated and the weight are updated. So weight in the neural network layer. So here we'll see there is input layer and there are multiple weights. So we can represent in the form of matrix. So W11, W12, W13, W14, W21, W22, W23, W24, W31, W23, W33, W34. So what does it mean? So here you can see what is W11. It is the weight from the input 1 to neuron H1. W12, the straight connection from H1, X1 to H1. So this is how it is interpreted and this is how it is represented in the form of matrix. So why weights are learnable parameter? Because the weights are updated through the outputs. So a network learn their values from the training data. And every time the loss function is calculated, that is error is calculated. And if there is error at the output layer, the weights are updated. So that's why the weights are called as learnable parameter. So at every iteration, you can see the weights are getting updated. So next is bias. So we gone through the weight. Now let us see the bias. So what is bias? Bias is a learnable parameter in the neural network that helps the model to shift the activation function and make prediction better. So there is input, there is weight. So summation of input and weight is calculated and then bias is added. So what is the importance of bias? So it is used to shift the activation function and make the prediction better. So this is the simple example of bias. Here weight value is 2, so 2x plus b. So if x is 3, b is equal to 1, then output is 7. But if here you can see if there is no bias, output will be 6. So bias gives a neuron an additional degree of freedom to adjust its output. So this is how the bias work. Now let us see the importance of bias in the neural network, why it is so much important. So bias shift the activation function. So first point, so bias is used to shift the activation function so that the neuron activate at the appropriate point. So here you can see if b is equal to 0, there is no shift. If b is greater than 0, it shift towards left. So neuron starts responding here at -2. Here it is responding at 0. So that's why bias is very, very important. Then allow output when input is 0. Suppose if input is 0, you can see here if input is 0, then output is also 0. But if input is 0 and if bias value is 1, then output will be 1. So that's why bias is very, very important. It allow output when input is 0. Help to create the better decision boundary. So bias will allow you to clear to draw the better decision boundary here. If bias value is 0, you will get output like this. But if there is bias, you can easily segregate the two entities. Here you can see there is perfect straight line between two entity, and this is possible only through bias. So improves learning. So bias definitely improves the learning at because uh, it is added with the weight and input, and at the end output is calculated. So if there is loss or if there is error, then what happens? Again, weights are updated. So there is definitely the role of bias. So in gradient descent and Adam algorithm, the bias is also updated along with the weight. So that's why bias improves the learning every time. So that's it for this video. I do hope you understand the concept of weight and bias in artificial neural network. If you like the video, then please subscribe, like, and share. Thank you.